All right, guys, we're going to look at worksheet 8B, which is word problems. We did 8A, solved by graphing on the calculator, which there is limited questions on the summative that have to do with solved by graphing, 1 or 2. But there are questions. There's also a question that with a word problem. Okay. This particular question, because I'm recording, I'm going to try to draw some stuff on here, but I also have a model to hold up and show you guys who are in class. Okay. But it says we start with a square piece of cardboard. So here's my square piece of cardboard. We would need a really big square piece of cardboard because we're supposed to cut out what size corners? 6-inch squares out of the corners. So we're going to go in 6 inches this way and in 6 inches this way, and we're going to cut out a square. Okay? And the same thing on each corner. All right, so now we have a piece that looks like this. This is going to be a really bad sketch, but it wasn't as bad as I thought it was going to be. All right, so we cut. Now, it had to be pretty big if we went in 6 inches from each side, right? So it had to be more than a foot across the piece of paper. This is my little model. But then what we're supposed to do is we're supposed to take and fold this up and tape it together so that it makes a box. Does everybody see how that would make a box? These kind of problems are huge in pre-calc. They're all over the place. We're going to talk about ones that have rectangular bases, ones that have lids, one that have fold-over lids. We're going to do all kinds of crazy business, okay? But this one, we're just folding it up. I didn't draw that very well. We're just folding it up so that we get a 3-dimensional box. And can you tell me any of the dimensions of this box right now? Something is 6. What is 6? The height of the box. Is everybody okay with that? Because when I folded it up, this was 6 inches here, 6 inches here, so the height, whoa, became 6 inches. The problem is I don't know anything else, okay? Except I know the volume of the box has to be 1,000. If I called this initial size, because that's what we're trying to find, I didn't read the problem here. It says a box with a square base and no top is to be made from a square piece of cardboard by cutting 6-inch squares out of each corner and folding up the sides. The box needs to hold 1,000 cubic inches. How big of a piece of cardboard were we needed to start with? So if I call this X, we need to figure out how big the cardboard was to start with. Does that make sense, guys? But when I folded it up, is this X? It's not, because remember this was X all the way across, and what did we do? We subtracted 6 from each side, so this new dimension is X minus 12. Yes? We're comfortable with that? Let me hold this up. Okay, so it was 12 here. I'm sorry, it was X out to here. We went in 6, we went in 6. So then this piece is X minus this 6 and this 6, or X minus 12. All right, what about going back this way? This dimension, if this is the width, this is the length, or the length and the width, what is this dimension? The same. Everybody's good with that? Because it's a square on the bottom, right? All right, what do you know about volume of a box? Yep, the area of the base times the height, or length times width times height, we like to say. All right, so can we put in some expressions here? Or numbers, or what can we put in? Okay, so one of these is x minus 12, another one is x minus 12, and the height is, and the volume we actually know is what? Okay, now we can solve this by dividing by 6, square rooting. It doesn't come out very nice. What's probably the more favored way for most of you to solve something messy? Yep, I would divide by 6, but it doesn't come out very nice. Some of you want to do this by graphing? Maybe? We have over here a 6 and an x minus 12. You don't have to do it by graphing. You can do it algebraically. This is squared. I'm going to just type it like that. Does that seem okay? And I'm going to put that in y1. And in y2, I'm going to put 1,000. And I'm going to see where they intersect. You don't have to do it this way. Algebraically is fine, because we're going to end up rounding to the nearest tenth anyway. But I want to talk about zoom fit. I hate zoom fit. I would be thrilled if you never, ever, ever used zoom fit. But some of these problems today, it would be okay to use zoom fit if you pick an appropriate x first. All right, let me type this in. What is an appropriate x for this? Can x be negative? Can x be 5? It actually can't be less than 12, right? If you're gonna, your original piece of cardboard had to be at least 12 if you went in 6 from each way. So you could set your window to be 0 to something, or you could set it to be 12 to something for the x window. And I don't know what a maximum is, because I don't know how far out. I have 60 typed in my calculator. I'm going to leave it 60 for a minute. See what happens. Now, this is actually one of the times when zoom fit is not going to be helpful. If I have 12 and 60 as my x values, it will choose y values if I go zoom 0, which is zoom fit. Oh, maybe it is going to be okay. It's not horrible. Do I see an intersection point in this window? Okay. I really only want to know when this hits what value. When the y value hits 1,000, right? So I probably would have said find the maximum at like 2,000 or 1,500 or something for the y max, because I know, I just want to know when it hits 1,000. So this isn't a horrible window. I'm not grading on a window here, so as long as you can see the intersection point, you're good. Does everybody have an intersection point somewhere in their screen? Okay, do you remember how to calculate that? Second, trace, which is the calculate menu, intersection. Now, it wants to know which curves or equations you want to use. As long as you only have those 2 equations in there, you can just hit enter. Be careful. You just want to hit enter enough times until it says intersection. If it doesn't say intersection anymore, you either went past, or if it says guess, you didn't go far enough. Okay, when it says intersection, I have an intersection value and it doesn't come out nice. Warned you. Okay, 24.9099. We could definitely use a piece of cardboard that was 25 by 25. The volume would just turn out to be a little bit more than 1,000. Okay? But our piece of cardboard needs to be at least 24.9-ish. I'm not going to be picky about how you rounded that. So how big a piece of cardboard is needed? Remember, it wanted both dimensions here of the original square. So 24.9 inch by, yeah, or square. You don't have to write it twice. If it's square, it's obviously 24.9 by 24.9. That seem okay? Anybody totally lost where we got any of that? Yes.
I got some weird intersection answer, like 0.9 something. Not even, I don't know what it's wrong with it.
Can you bring your plot up here? Remember your intersection again. Because you had a plot on, I think it was using your list as one of your values that it wanted to find the intersection of, okay? See if that works. If not, I'll look at it again.
No.
Is it good now?
No.
Is it in your window? Oh, you're getting a negative value.
Yeah.
Okay. If we look at the picture again, there are actually two places where this would cross, yes? Let me go back to my picture here. I meant to talk about this, so thank you for asking. If this parabola would go up on the other side as well, yes? So it has another intersection point. But remember what the first thing I said was? X value has to be what? Positive and greater than 12? So if I reset my window to like negative 20 to 60, I can see both intersection points. But can X be negative 0.9 over here? No. So you need to just make sure within your window is a positive intersection point. That's a great question, though, that I should have addressed. All right, let's try 7. This one is a little confusing because it doesn't say what shape. A farmer wishes to enclose 3 pens with fencing as shown. If the farmer has 700 feet of fencing to work with, what dimensions will maximize the area enclosed? So, we don't know if these are squares or rectangles, but we do know that he's going to fence this distance, and this distance, and this distance, and this distance, all the same amount of fence, right? To split this into 3 parts, do you see what I'm talking about here? So these would all be X. And I don't really know if these are longer than X or the same as X. So I'm just going to call this dimension Y. I don't know what this is. However long that side is. It could be 3 X's, but I'm not sure that it is. All right. So what does the 700 have to do with? How much fence he has. So what could we say with an equation that has that 700? Anybody know? When he starts cutting all these chunks of fence, it can't total more than 700. Vesma? Does that seem okay, guys? He's got to cut 4 X chunks and 2 Y chunks and go out there and put the fencing down, and it's got to be 700 or less. We're going to go with 700 for now. But he wants to maximize the area for his animals using this fence. What is the area of this shape right now? Yes. Does everyone see it's just a rectangle? The fact that it's cut into parts doesn't really matter. The total area is still X by Y. So X times Y is what we're trying to find the maximum of. It's the area, right, that we want to maximize? Okay. I don't do two variables so well. Is there a way we could replace one of those variables with the other? The little substitution action? Which one do you want to find first, x or y? Doesn't matter. I want to find x. Okay, so we're going to solve this for y. So we'd have 700 minus 4x, and then what would we have to do? Divide by 2. What would that become? 350 minus 2x, right? We're not going to kill any kittens here by dividing one of them and not the other. Got to divide both of them by 2, yes? All right, now can I substitute that into here? So now I have the length or width or height or whatever we want to say of our picture up there is x, and that y value is really 350 minus 2x. Okay, why was that helpful? Well, got us down to one variable. But what shape is that graph? If I distribute 350x minus 2x squared, it's a what? It's a parabola. It's a parabola that opens negative 2x squared, right? Minus 2x squared opens down. So does it have a maximum? Ah, there we go. Okay. So we can type it in our calculator and find the maximum. We're not finding an intersection point this time. We're finding the maximum. You can distribute it if you want, or you can type it just the way it is. So really putting in one equation, x times 350 minus 2x. And we want to maximize this. Okay, what's an appropriate window this time? Can x be negative? Nope. It can't be 0. You're right. I think his animals wouldn't fit in there, right? If there was 0 width. I could leave it 0. I don't really know how big it goes. I'm just trying to find the maximum. I don't know. I'm going to leave this 0 to 60 and then do a zoom 0 to find... Oh, it's not in my window, is it? I didn't go out far enough. 0 to 200? I don't know. And then to set the y value, again, you can do a zoom 0 because it will find an appropriate... Now, is this really an appropriate window? Can I have negative area? But will I find the maximum in this window? That's all I really care about. Did everybody get some kind of a window that has a maximum? I did 0 to 200, and then I did zoom 0. 0 to 200 for x. Okay, so go to your window, put in 0 to 200, and then don't worry about the rest. Just hit the zoom and the 0 button, and it will pick y values for you. Did you get it, Sarah? So you have some kind of a maximum. Okay, now find your maximum. So second trace, find the maximum, and I'm just going to say it's somewhere between 0 and 200 because I remembered that that's my window, but you can find it by scrolling around. Anybody getting 87.5, right? I have a little bit of calculator error, but it's 0.499985. So it actually gives me the x value of 87.499. It's 87.5, sorry. Let me just round. I don't want you to be... Did somebody get 87.5 exactly? 15,312.5? Nobody got 87.5 exactly? You got a 0.0001? Did anybody show up 87.5? Yeah. Okay, just calculator error because it's using smaller and smaller intervals to find that. All right, so what is this telling us? And don't let me forget that I should have probably talked about how to find this one algebraically as well. But what is this telling us? It says, what are the dimensions? So this dimension should be how much? Yes. By what, though? This is where everybody got really confused earlier today. This dimension is not 87.5. What are we going to do this way? We got to find y. Where can we find y? How about right here? Right there? Did it say 350 minus 2x? So 350 minus 2 times 87.5 is 175? So the dimensions that he enclosed will be 87.5 by 175.5, and then he'll split it into the 3, and he will get a total area, right? If we wanted to know, whoops, I didn't draw that very well. His total area would be this 15,312.5 square feet of area enclosed. I wanted to talk about real quick, when we had the area equals and we put 350x minus 2x squared, if we had typed, how could we have found the maximum? The maximum is really where? At the vertex? And how do we find the vertex? We have a recipe. Negative b over 2a, right? So b would have been 350, because I don't have it in the right order here, over 2 times a. Do that for me. Negative 350 divided by negative 4. Got exactly this time 87.5, right? So algebraically would have given us that, and then we would have still had to plug it back in to find the rest. All right, so that was algebraically. All right, 8 and 9 are very similar to each other. 8 and 9 are finding maximum revenue with some changing features. Did I see her? Negative b over 2a. That's how to solve it algebraically. And that was, if you had, this would be your ax squared plus bx plus c form. So we just plug those in. Does that better? Okay. Number 8 says a salesperson finds that her sales average 40 cases a week when she visits 20 stores a week. If she visits an additional store, her average sales per store decreased by 1 case. Okay. I don't know what she's selling. We'll go with Snickers bars. How's that? Okay. She sells cases of Snickers bars. She goes to Schnucks. She goes to Walgreens. She goes to Walmart. She goes to all these different stores. She walks in. She schmoozes with the manager and says, you want to buy some Snickers bars. Okay. If she, during the week, goes to 20 different stores, her average sales are 40 cases per store. So how many cases is she selling at that rate? When she goes to 20 stores, she sells 40 cases per store, or 800 cases. You don't have this little chart, I don't think, on your paper, but it kind of helps to think about what's going on. It says if she visits an additional store every week, her average sales actually decrease by 1 case. So she spends a little less time in each store, rushes a little bit faster, but she ends up selling 1 less case, but going to 1 extra store. Is that a good deal or not? How many stores would she visit? And how many cases would she sell? And what does that come out? So is that better? She's still making more money, right? She's selling more cases. We need to find a way to maximize the number of cases she sells. We can do this one more time just to make sure we get this. This one's going up by what? One more store, yes. And this is going down by one case. 836. Okay. Now the issue becomes, what are we going to let X represent, and how are we going to write an expression so that we can maximize this? How many stores per week should she visit? I'm thinking we should let X be the number of additional stores that she's going to visit. So what did this one start by in this column? And it's going up or down by ones, which is 1x. What about the cases? It started at 40 and it's going down by one case every time. If schmoozing meant it went down by 2 cases, then we would have to do 40 minus 2x. We're going to see one by that, like that in a minute here. But this is started at 20 going up by ones. This one started at 40 going down. And how are we getting this third column? We're just multiplying those. All right. If we smush that all together, would we get a parabola, a quadratic equation? I think we'd get 800 minus 20x minus x squared. But you don't have to do that. You don't have to FOIL it out if you don't want to. It is a parabola. It should be plus 20x, shouldn't it? Did I FOIL it right that time? It's a parabola that opens down. I'm just going to use the original expressions of 20 plus x times 40 minus x, and I'm going to graph it and find the maximum. Now think about that. Look what you just typed. 20 plus x. X can be infinitely large. But 40 minus x. Can she have negative cases sold? So we can't go to more than 40 more stores, right? Because 40 minus 40 would be 0. She wouldn't be selling anything. So knowing that, I'm going to go to my window and set my window from 0 to 40. I know it's not going to be as high as 40, but I know that's a ballpark. And then I'm going to do what if I want to find the maximum? Yeah, I'm going to do zoom 0. But it only works if you set the x up first, guys. Ooh, nice. Can we see the maximum in this window? Okay. So rather than having to play around and find the maximum, we use the zoom fit to find the maximum in the window here. Choice 4 is maximum. Everybody okay? Second choice 4, maximum. Now it asks for left bound and right bound. I'm just going to go with it's somewhere between 0 and, I don't even remember what I made it. 40? Thank you. You could just scroll around if you want. It's not really a very good window because it's cut off at the top. But did someone else find a maximum of 10? Okay. 9.9999. Okay. So if the max, I got 10.00003, but the max is about 10,900. What does that mean? Okay, she should go to 10 more stores. She'll sell 900 cases. Okay, but I don't think we answered the question yet. How many stores per week should she visit? The 10 is the number of more stores she should go to, right? So if we put the 10 in here and the 10 in here, she'll actually go to 30 stores and she would average 30 cases and 900 cases sold for the week. All right, let's try 9. It's just a little bit different. Same idea. Okay, so we have a potter. We don't know if it's male or female. Since the last one was a she, I'm going to go with a he here, okay? Our potter sells 120 bowls a week. So right now he's selling 120 bowls. And he's charging $4 a bowl. So how much money is in his little cash box if he sells out? $480. It says for each 50-cent decrease in price. Uh-oh. It's not going down 1 this time. What's the price doing? So the next one would be $3.50, or we'd have $4 is going to repeatedly drop by 50 cents. I don't have a lot of time left, so I'm writing the expression at the same time. So X is going to be the number of price drops. Did that seem like magic, or you get where I'm going with 4 minus 50? He's going to subtract 50 cents over and over. How many price drops before he's not making anything? If you have $4 and you take off 50 cents 8 times, and you'd be giving your bowls away, right? So we know X can't be more than 8 for our X window here. All right, back to this expression. What happens with the bowls, though? Yes, 20 more bowls. So the next one would be 140, or 120 plus 20 every time. Sells 20 more every time he drops the price. All right, what is 140 times 350? 490? Okay, so it was going up. Let's see. Okay, tell me what to do. Put those in, and what are we going to do to find a good window this time? Why was it 20x? Somebody explain that to me one more time. Because it said he's going to sell 20 more bowls. And why was the other one minus 50? Because he's not dropping the price $1, he's dropping it 50 cents over and over, right? All right, we decided the window could be only 0 to 8. If I have in 0 to 8, and then I do a zoom 0. Again, I'm not fond of this window because it's cut off at the top kind of here, but do you see the maximum is in the window? I actually already found it. Okay. If we do second trace, to calculate, we choose maximum. It's somewhere between 0 and 8. I got 490. Why does that sound so familiar? Yeah, because this was kind of a gimme question. Because this one right here was the actual max. So what's the answer to the question, though? What price should we charge in order to maximize revenue? Okay, $3.50 per bowl. How many would they sell? 140 would be sold for a max revenue of $490. It really only asked how much to charge. This is what it asked for right here. All right, I know I went through that really quickly. We actually have a couple minutes left. I'm going to talk through one like the one on the test. So anybody who watches the video, and you, my favorite class ever, right, will get a hint of what's on the test. The question on the test says something like this. I'm going to make a rectangular garden whose area is going to be, and I'm making up a number here, 1,200 square feet. Okay, but whose perimeter This should be square feet. Whose perimeter is 150 feet. How could we do this? Okay. You are right. I'm going to start out by talking about this, though, okay? If this is my garden, guys, the question would be find the dimensions. So somebody tell me something about this garden. Two equations. X times Y is 1200. Everybody okay? 2x plus 2y is the perimeter of 150. Yes? Okay, so what she said is divide all this by 2. So we have x plus y is 75. Or y equals 75 minus x. So we have x times 75 minus x. Is that a parabola that opens down? We want to know when it hits a value of 1200. Okay, help me, I forgot. X times 75 minus x. And 1200. And then my window, I'm going to go 0 to 75. And I actually want to go, I'm going to set it this time. I want to go up to 1200, right? I'm just going to put in 1500 so that I can see. Ooh, two numbers. Why are there two solutions? One's actually the length and one's the width. Let me show you what happens. If I find the intersection, doesn't matter which one I find, I got 23.1. What do you think? What's 75 minus 23.1? 51.9. So let's see if that's the other intersection point over there. $51.9. Okay. So the dimensions would be 23.1 feet by 51.9 feet to give you an area and a perimeter of this. Okay? There's a question like that on the test. Area and perimeters formulas everybody should be good at, right? Okay. So remind me, and we can do another one of those another day.